Hello again. We are going to start a new unit. This is a trigonometry unit. So we're going to start by talking about the basic trigonometric ratios. This is lesson 9.1. So let's get started. We're going to start with an angle in a right triangle. That's what all trigonometry is based on. It's based on right triangles and picking one of the acute angles, not the right angle, but picking one of the acute angles that's in that right triangle, and we're going to call that angle theta. That's a Greek letter. So once we start talking about angles, we don't use the typical alphabet anymore. We switch to the Greek alphabet, usually. Some people will use the regular alphabet for everything. So based on the angle that we chose, we're going to name the three sides: the hypotenuse, the opposite, and the adjacent. Now the hypotenuse is always going to be the longest side. It's always on the opposite side of the triangle from the right angle. And it's always like the diagonal side, if you want to think of it that way. The opposite is going to be the side that is furthest away from the angle that we've called theta. So that's going to be called the opposite. And then the side that is touching that angle theta, or is next to that angle theta but is not the hypotenuse, that's going to be called adjacent. And that's just because adjacent is a word that means to be next to something. Alright, so we can take any two of these sides and make a ratio or a fraction out of them. For example, I can make a fraction by putting the length of the opposite over the length of the hypotenuse. I can make another ratio by taking the length of the adjacent and putting that over the length of the hypotenuse. And finally, I can take the length of the opposite and put it over the length of the adjacent and make another ratio that way. Those are the only three combinations I can do, unless of course I switch all of those fractions and put them upside down. But those are the only ways I can choose two of the three sides and make a fraction. And luckily, all of these ratios already exist and they already have names. So the name that has been given to the opposite over the hypotenuse is the sine of theta. So once I have an angle or an angle measurement, then the sine of that angle measurement will always be the ratio of the opposite side to the hypotenuse. And similarly, if I use the adjacent and the hypotenuse, that has been called the cosine of theta. Okay, so if I have an angle, then the cosine of that angle will always be the adjacent over the hypotenuse. And lastly, tangent. The tangent of theta has been defined as the ratio of the opposite side to the adjacent side, always. All right. And the way I remember this is sine is opposite over hypotenuse, SOH. Cosine is adjacent over hypotenuse, CAH. And tangent is opposite over adjacent, TOA. So I can remember the 9-letter word SOHCAHTOA, and that will help me remember which ratio has which two sides associated with it. That helps me not only with memorizing how to calculate each of these, but it also helps me in problem solving when I have some information and I need to know which ratio to use to actually solve the problem. Alright, so now if I change the angle, there are two acute angles in this triangle. So if I decide to talk about the other one instead, then what happens is the side that was opposite the first acute angle is no longer opposite the new angle, and the side that was adjacent is no longer adjacent. So I have to switch those two sides so that now the bottom side is called the opposite because it's now opposite the new theta. And the right side is going to be called the adjacent because now it's next to the new theta in its new position. All right. But the hypotenuse, by definition, is just the longest side of the right triangle, so it can't go anywhere. It stays where it is. I can't call it anything else. All right, so in the following triangle, and just to make things clear, rather than use the Greek letter theta, I'm using two other Greek letters, alpha and beta. And I'm going to call the lengths of the sides of this triangle P, Q, and R rather than calling them opposite, adjacent, and hypotenuse because that's going to change depending on whether I'm talking about angle alpha or angle beta. Okay, so the sine of alpha is going to be the opposite over the hypotenuse, which in this case is going to be Q over R. The cosine of alpha is going to be the adjacent over the hypotenuse. That's going to be P over R. And the tangent of alpha is going to be q over p, the opposite over the adjacent. Okay, when I switch and talk about angle beta, now p is the opposite and q is the adjacent, and r is still the hypotenuse. So the sine of beta is p over r, the cosine of beta is q over r, and the tangent of beta is p over q. Now I want you to see the relationship between the sine, cosine, and tangent of alpha versus the sine, cosine, and tangent of beta, particularly the sines and the cosines. If you look at the cosine of alpha, it's exactly the same as the sine of beta. And similarly, if I look at the cosine of beta, it's exactly the same as the sine of alpha. So cosine actually means the sine of the other angle. So the cosine of alpha is the sine of beta, and the cosine of beta is the sine of alpha. That's literally what cosine means. It means the sine of the other angle, the other acute angle in that right triangle. So how does this help me? Well, if I have a 30-degree angle, I'm done talking about variables, so if I have a 30-degree angle, then I can figure out on a calculator what the sine, cosine, and tangent is of that 30-degree angle. I just need to type in sine 30 or cosine 30 or tangent 30, and it will give me a decimal. Okay? So if I actually do that, type in sine of 30, it equals a half, or it equals 0.5, whichever form you're used to. So what that means is the ratio of the opposite to the hypotenuse is always 1/2, which means that the hypotenuse is always going to be twice as long as the opposite, as long as there's a 30-degree angle at one of those acute angles. So for example, if the hypotenuse is 34, then the opposite is 17. Similarly, if the opposite is 46, then the hypotenuse is 92. Okay, that's every 30-degree angle in a right triangle. That relationship is going to hold. So that's just an idea of what the sine tells you about those sides of that right triangle. So, for example, I have a right triangle here. I have a 56-degree angle up top. I have 80 and x. Now, the first job is to figure out, based on where my angle is, what two sides am I dealing with? Well, 80 is the hypotenuse, and x is the adjacent because it's next to the angle. It's touching that angle. So I need to use the ratio that uses the adjacent and the hypotenuse. Remembering SOHCAHTOA, I'm looking for the triple that has A for adjacent and H for hypotenuse, since that's the two sides that I've been given, the two sides I'm working with. And that is cosine. So the cosine of my angle theta is always the adjacent over the hypotenuse. So now that I know which ratio I'm using and what it's equal to, I can start substituting in letters and numbers. So the cosine of 56, which is my theta, is going to equal the adjacent x over the hypotenuse 80. So now I only have one unknown, that's my x. Usually I'm going to end up working with fractions, so when I solve these questions I typically cross multiply. That gets rid of the fractions and I can just solve by multiplying or dividing by whatever I need to. So that's what I'm going to do in this case. I'm going to cross multiply and get 80 times the cosine of 56 degrees equals x. Okay? And so now I know what x is. It's 80 times the cosine of 56 degrees. My calculator can tell me what that is as a decimal. That's 44.7. So that's how long that right-hand side is in that triangle, based on the other information I was given. Okay, here's another example. Now I have a 42-degree angle, and you can see where it is. I have a 91 and I have an x. Well, what two sides are those? Based on where the 42-degree angle is, 91 is on the opposite side of the triangle, so that's my opposite. X is touching the angle, but it's not the hypotenuse, so it's the adjacent. So I'm looking for the triple at the bottom that has O for opposite and A for adjacent. Well, that's the TOA, and the T stands for tangent. So I'm going to use the tangent of theta, which always equals the opposite over the adjacent. Now that I have that written down, I can plug in the information that I need. The tangent of 42 degrees, which is my angle, equals the opposite, 91, over the adjacent, x. I cross multiply, and I get x times the tangent of 42 degrees equals 91. So since x is being multiplied by whatever the tangent of 42 is, I will divide by that amount. So x is going to equal 91 divided by the tangent of 42 degrees. That's going to be 101.07. So that's the length of that bottom side in that triangle. Now, the only other thing I can go over with you is how to find the angle. We've talked about how to find missing sides, but sometimes you need to know the angle. Okay, so looking at this triangle again, I can see where theta is. I have two sides now, 92 and 127. Well, what are those sides based on where theta is? Based on where theta is, 92 is the opposite because it's on the opposite side of the triangle, and 127 is the hypotenuse. So looking at the triples, I need to find the triple that has O for opposite and H for hypotenuse. Well, that's the first one, SOH, and the S stands for sine. Okay, so I will use sine. Sine of theta is always equal to the opposite side over the hypotenuse. And so now I can fill in the numbers that I have. The sine of theta, it's still called theta, equals 92 over 127. Now I know what you're thinking. It looks like theta is being multiplied by sine. That's not true. The theta is the argument of the function sine. Sine is not a thing that stands by itself. It is a function that requires an input. So it is not sine times theta. It is the sine of theta. So that's a function. So in order to undo that function and get theta by itself, I have to use the inverse function of sine. And luckily there's a button for that on your calculator. The inverse of sine is inverse sine, and it looks like sine to the exponent -1 on your calculator. So if I do that to the left-hand side, the inverse sine of the sine of theta, since those two functions are inverses, those are going to cancel out. And on the right-hand side, I'm going to have the inverse sine of 92 over 127. And that's something you can type into your calculator. And if you do, you will get theta equaling 46.4. So that's how you find the angle. If you ever want to find the angle in one of these triangles, you're going to have to use either sine inverse, cosine inverse, or tangent inverse. And you can tell those because they've got the little -1 exponent in their notation. So that's the beginnings of trigonometry. If you have any questions, please let me know, and I will see you tomorrow.